Hi class, we're going to look at example 2 and example 4. Now, both of these examples, we're actually told that the data is bell-shaped. So just to clarify, if the data is not bell-shaped, you're going to be using Chebyshev's rule. And if it's actually bell-shaped, you're going to be using the empirical rule. Also, I wanted to clarify or further clarify that when you have symmetrical intervals within one standard deviation on both directions, you have 68%. For two standard deviations, that means two above and two below, about 95, and approximately 99.7 within three. So that means that you have a total of symmetrical intervals. Now, as we're actually looking at spread of data, you have to look at, do you have symmetrical intervals or not symmetrical intervals? So for instance, within two standard deviations, that means you do have symmetrical intervals. That means you're going to go up 2 and below 2. But example 4 is actually not symmetrical. So let's actually take a look at the solution. So in this case, I just went ahead and typed up the relevant information. So you technically have, for example 2, this is the value of the mean, and then you're going 1 and 2 all the way to 2 standard deviations, and then technically also 2 below. But automatically by the empirical rule, you have approximately 95% of the data. So you're always providing a sentence, and then your sentence for the empirical rule or data that's bell-shaped, you have to include approximately. This is an estimate because there's a little bit of rounding within the actual actual areas that they're calculating, meaning above or below. Here I'm using software just to display, and you can actually see that yes, that's approximately 95%, but there's a little bit more. So hence in your wording, you're always stating approximately. For the empirical rule, for Chebyshev's theorem, the wording is at least. And then also in your sentence, you have to mention that you're technically going up 2 and technically below 2 standard deviations above and below the mean. So for this example, this one's standard. Example 2 is standard. It's just asking about 2. Make sure that you have the wording. Let's take a look at example 4. Now, example 4, it's actually not symmetrical. And because we don't have a symmetrical interval, there's a little bit of a calculation that needs to be done. So give me a minute. Okay, as you do the calculations, this is technically the mean, and the one above it, it says you have a total of 3. So this value is 3. If it was symmetrical, then you would have within 3 a total of 99.7. That means that it would go all the way to 3 on the actual negative side. But in this case, you only have 3, or more importantly, half of 3. And then below, you only have 1. So that means that we actually have to do the following calculation. You have to make sure that, well, for fully even intervals, the total data set is 68, but we don't have that. We actually have half of that, so you only have 34. So that means that this portion here, let me circle it up, that represents your 34% of the data. Now, as we look above it, it's only half of the 99.7. So that's going to give you this much. So that represents, and maybe I should put that in a different color. That represents half of this chunk. So this chunk, not including the within, meaning 3 standard deviations below, that's going to give you half of 99.7, which happens to give us 49.85. Now, for the total data or percentage of data that's within, that's actually, that is 1 below and 3 above, you have to add them. So in this case, we're getting approximately 83.85. Let me double check that calculation. Yeah, 83.85. And you will notice that, well, here on the actual software, it's a little bit off, but that's perfectly fine. I'm using the percentages that the empirical rule is providing. And then once again, your sentence has to state the approximate area, and then also the interval. So in this case, your interval is just 1 standard deviation below and technically 3 standard deviations above, but they're not symmetrical. Okay, that's actually it for the second problem. As I mentioned, it takes a little bit more work because it's not symmetrical, so you cannot automatically read it off the actual empirical rule. Also, another thing I wanted to mention is the total area under the curve. It's 100% of scores or 1.